Okay. So before the connection went off, we emphasizing on the concept of objects, where I think it's clear already. The concept of object is clear for everybody, right?
Yes, sir.
Is it clear?
Yes, sir.
Okay. And what we were explaining is this point: an object stores its state in fields that are variables in programming languages and exposes its behavior through methods. And these methods are what? They are functions in some programming languages. Okay. Okay. So it has a state, and that state could be variables. And then the behavior is through functions. Now, building code into individual software objects provides a number of benefits. When you write programs or using the object-oriented approach, you have some benefits. The benefit of modularity means you can handle an object as an independent component, okay? It means when you have two objects, maybe in your program, you have an object student, you have an object course, you have an object hall or classroom, you have an object textbook. You can handle these objects independently. Okay, if you have a problem with your program, you can disable the student object, and all the other objects will still be there working well. Okay, so it enables this modularity, permits you to work with objects, tackle problems particular to or peculiar to particular objects without necessarily affecting the whole program. Okay, we have this information system. Okay, I'm sorry, information hiding. So it means what? It means that an object, you can decide which methods of the object you are exposing to the outside. For example, we saw that in a student object, especially for girls, girls would not want people to know their date of birth or their something like that. If you want to hide this information about the object, you don't provide a method for other people to see this information. As simple as that. You can hide this information from your objects, okay, as you decide. So you can have some states or some characteristics of objects that you don't present it to people or to everybody. You select the particular audience to present these characteristics. Okay, so we have also the concept of code reuse. Means it is possible for you to use already existing objects. If you're writing your program and there is an object that is already existing that was written perhaps by another developer or programmer, you can use this object in your program. And what you need is, you don't need to understand the details of what is in this object. You just need to know that which method can I use. If you know that I can call, for example, if there is a method that is doing calculation, maybe that is calculating the average of, I don't know, or the GPA of a student. If there's a method existing for calculating the GPA, you will not need to go again creating this method. Maybe this method was written by another person. You just get that method and then you reuse it. You check. What you need to check is that, how do I interact with this method? If they said to interact with this method, you need to provide two or a list of marks. You need to provide a list of marks. All you need to do is prepare the list of marks and you inject it into this object and it will calculate your GPA without you needing to know the details of what is happening in order to calculate the GPA. So working with objects facilitates this code reuse, okay? We have pluggability and debugging ease. So it is easy for you to inject a new object into some other code or some other function that is existing. And it is easy for you to identify where there are faults, okay? To debug errors in your program. If there are errors, you identify easily that this is the object that is causing the error in my program, you go directly to that object and you solve the problem. So these are some advantages that you will have working with object modularity, information hiding, code reuse, and then pluggability and debugging ease. Okay. Now, how do you create objects? How do you create objects in Java? Okay, you create objects using the new operator, new. It means if there is an object that was existing that was called box, okay, you can just say, you will just say box, you give the name of the new object you are creating, which is box1, and you just say equals to new box, and then you create your new object. That is how you create your object in Java. For example, and most of these objects are created from classes. Imagine you have a student. You have created a class, a template called student. A template called student, you expect that every student will fall into this category, or we have these properties. For example, if you define a template called student, you will know that there is something that is common for every student. They must have a name, they must have a matricule, they must have date of birth, they must have place of birth, they must have all these, they must have that. So every other student. So in this class, in this our course, we can create a template student. And we will now say, okay, I want to create a student called Blaze. I will say student Blaze equals new student, and I'm creating a student, okay? And I will say again, student Clinton equals new student. Student Evani equals new student. Student Asobo equals new student. And like that, I'm going to create all the students in my class, all the students, just knowing that all of them will have the same property, okay? So this is definitely how you will do it. You will create, you will just say a student, you create the first student, and then you use this new, and you create your student, okay? And then in Java, you will not need to destroy your objects, because once you create the objects, the programming language takes care of moving these objects that are no longer needed. Okay, that's why we say Java automatically flags unused objects and applies garbage collection when appropriate. So Java takes care of the destruction of objects for you. But in any case, you can still use the method finalize in order to create or to release your objects. Because when you do that, you also release your memory, you release the computer resources, okay? So when you do void finalize, it will do what? It will finalize and it will free the resources for this object. But even if you don't do that, the programming or the Java will automatically flag those objects, those unused objects, okay, and remove them. And then to access objects, we have seen, you see, look at what they have done here. In fact, you want to access an object that is found somewhere. It is an object E. You have created an object E that is of type employee, okay? This is how you do it. You say employee E equals new employee. You finish it with close brackets like this. So you have employee, which is the template or the class, and then you have the name of the new object that you're creating is E. So now you can do what? If you know that in employee there is name, you can do E.name, okay? When you do E.name, you means you want to access the name of this new student E that you have created. And you can say E.name equals R Bundy, for example. It means you are setting the name of this new student that you are creating to be Bundy, or the name of this new employee to be R Bundy, for example. Okay, so if it means all of us are workers, maybe we are workers, and I want to create, I've created a template or a class for employees. I can then say, okay, employee E If I want to create for Clinton, for example, or for Evania, I will say employee E equals new employee. And then I will set the name. You know, at the back of all these things, you will have a database that you'll be inserting this information in. I will then say E dot name should be equal to Al Bundy or Evani, for example, and I'm setting the name of that. And I'll say E dot set salary. He's touching just 100 or 1,000. This should be 1,000 US dollars. You people are more than 1,000 francs, so you are my future engineer, so they should not pay you this kind of salary. Okay, so you can do this. So just know that you can create objects like this. When you have your class, you can create as many objects as possible belonging to the same class, and you can set their variables, access the objects like this. The name is inside this E. The salary is there. You can access those methods and you can update your methods, your objects. Okay, now we are talking about classes now. I think when you understand the concept of classes, or you have understood the concept of objects, the classes will be very clear. Because what is happening, look at the beginning. We did something like public class. So you will see that all these objects are being created because there is a class actually. When you come and say, like what we said here, that box, box1 equals new box, okay? It is because there was a class that was existing that is called box. When you did this, employee equals new employee, there is a class that is called employee, and you are simply creating an object of that type. So it means a class is simply like a factory, a kind of a factory that will enable you to create objects, okay? And you will see that objects of the same class behave the same way. They have the same states, the same features. They respond to the same messages in the same way, okay? Like they are, let me say, they are identical. Objects of the same class are identical. For example, you can create a class student. When you create a class student, you will create object 1, which is Clinton. Object 2 is Asobo. Object 3 is Evane. Object 3 is Blaze, for example. So you will see that you have created a class which is like a template, and you can create as many objects of this template as possible. Okay, and you will record them in your database like that. And each of these objects will have all the characteristics that you define for this class. Okay, so we are going to see that in the definition of a class, this is the general syntax. We have the modifier, and we saw that this modifier was could be public, it could be private, and then you have this keyword class, and then you have the name of the class. You have the name of the class, and this class could be what? Normally, they said the name of the class should generally start with the capital letter. That is the convention of the Java programming language. So that when you be creating objects of that class, you can use small letters. The class itself, the class name should start with capital letter. Okay. Now we are going to go straight to look at an example. So look at what they say here. They say a class is the blueprint from which individual objects are created. So a class is like a blueprint or a template from which you can create objects. And in this example, which you are also going to run and execute, this is the second assignment, right? Yeah, that is the second assignment. The first one was a simple Java program. And in that simple Java program, you should make it to display hello world. You should make it to also display your name. It should display hello world, and it should display your name. And your work should be submitted in PDF format. You will send the screenshots. The screenshots will show the code and the screenshot will show the output. When I say like this, some people will go and show screenshots showing just the output without the code. And when I give them 1/100, they will complain. So give your screenshots containing all the elements that is required. Show the code in the screenshot, show the output or the results. And the results should show that it is showing hello world and it is also showing your name. Okay. All right. So this is let's quickly look at this example. We still have about 14 minutes. So let's quickly look at this. You have a couple of programs to run here. Okay, so this, we have seen that a class is like a blueprint or like a factory for creating objects. It means if you want to write your program that is going to record all the students of the Faculty of Science, not so. All you need to do is to create a class student, and that is all. When you create a class student with all the properties of the student and all the methods, then you can always create as many objects of this class as there are students. If there are 100 students in the Faculty of, or let me say there are 100 students in the Department of Computer Science. If there are 100 students, you simply just create a class student, and then every time there is a student, you will just create an object of that class. You say student S1 equals new student. And then you do that, you record the student like that, okay? And each year, every time there's a new student, just create the student equals new student, and you add it to you add objects like that, okay? So each time you will not need to go to the details. What is the student taking? The student has the first name, second name, last name. No, you don't need that. Since you have created a class with taking into consideration all the attributes of student, each time there's a new student, you just create an object of class student and then you give them their properties, and that's all. So this example is showing us about the bicycle. There is a class bicycle. If you like, you put your public class or public static class bicycle. And then look at what they are doing. They are declaring some variables. These variables are characteristics of the bicycle. We have an integer cadence that is initialized at 0. We have the speed that is initialized at 0. We have gear that is initialized at 1. And all these properties are of type integers, okay? This is how you declare variables in programming language. Int the name of the variable and initialize it to 0. Okay, you could just do int cadence without initializing, but in this statement they are setting the initial values. Okay, and then there is a first method that they are declaring for that they are creating for this class. The first method is change cadence. And that first method has this modifier is void. It means it is not returning anything. It is returning nothing. It is not returning anything. So when they say change cadence, this method is taking into value some integer. And it is doing what? It is resetting cadence. It means that if you call this method, right? If you call this method change cadence for this object bicycle, the method will ask you, what is the new cadence that you want to put? The initial cadence was 0. If you want the cadence to be 10, you will just call this method and put 10. And this method will do what? You set this cadence from 0 to 10. Okay, so it means the cadence of this bicycle will now be 10. Change gear is another method, and it is taking into parameter some value. So if you call this method change gear, for this bicycle, they will ask you, you want to change gear. What is the next gear you want to put? You should enter a gear. Maybe you want to change gear from 1 to 20. You will just say, you enter 20, and then the gear of the bicycle will now be at 20. Okay. There is another method that is speed up. Speed up means to increase the speed of the bicycle. Okay. So when you call this method, the method will ask you, for what do you want to increment the speed? Maybe your bicycle is running at 2 meters per second. They say you want to increment it by 1, for example. When you call this method speed up, it is going to ask you, speed up by how many? You provide 1. And then the method will do what? It will take the speed that was there and it will add 1 to that speed. And your new speed will be, and you notice that your bicycle will now roll even faster, okay? It will roll faster because the speed has incremented. You have called this method. And then you have this apply brakes. If you want to apply brakes, okay, it should be a decrement. We want to apply brakes by how many? Just by slowly. Or you want to apply it abruptly by 100 at once. If you apply by 100, it is going to do what? Take speed, it is subtract the speed, and it will set the speed at that. So if the speed was initially 20, I want you to bring the speed to 10. You are going to apply brakes, calling and inserting 10 here so that it will bring it back to 10, from 20 to 10. It will subtract. Okay. So these are some of the things that you need to know. And then you can print the states of you want to have maybe a dashboard that is displaying to you the status, all the status of your bicycle, the cadence, the speed, and the gear. Maybe you are running your bicycle and you need to see what is your speed at which you are running, what is the cadence, what is the gear. You can have this method print for a print state that is showing you. This method will now use a system out print element that is showing you the cadence, it is showing you the speed, and it is showing you the gear of your bicycle. Okay, so this is a typical example that you can apply, and it is like you have when you're riding on your bicycle, you have a dashboard. These are things that you do on your bicycle. You add speed, you apply brakes, you do this, but now you can also implement them even in a program, in a computer program like this. Okay, are we together? Am I speaking too fast? I'm making a lot of noise.
No, sir.
Yes, sir. Yes, sir.
Huh?
Yes, sir.
Yes, that the rhythm is good, right?
Yes, sir.
Okay, okay, good.
Everything is okay.
All right, fine. Okay, so this is basically what you have. So you should have this in your mind, or in your this vision. This is the vision that you should have. You should not think that it is very complex, but these are real life situations that you can bring them to the computer. You can bring them to the computer. For example, if you are taking a situation of a student, you can define a class student, for example. And a student, you will have what? The name. Name might be string or character name. You will have what? Date of birth, date. You have all these properties that you have about students, you will list them here, okay? You will list them with their respective types. If it is int, if it is character, if it is Boolean, if it is float, if it is what. When you list them now, you will now look at the methods that you will use to get these variables that you will expose to the outside in order to manipulate. If you want to display all the information about a student, you simply write a method print, maybe print the state of a student, and in that method, you will say that it should print the name, it should print the date of birth, it should print that, and you will be able to see information about the student. If you don't want to see the age of the student, in this your method, you should not add print age. For those who are hiding their ages. So you should know which one you are exposing about your object and which one you are hiding. Okay, so that is basically how it is. And this is a demo class. There is a demo application that is implementing this bicycle method. Okay, you are going to execute this program as well. If you have difficulties, you indicate. So you are going to create a class that you call bicycle demo or any other name. Then you will do what? You will create two different bicycle objects. You will create bicycle, bike 1, bike 2. And for bike 1, you are going to invoke some methods. Bike 1, you are going to change its cadence. You are going to do this. In fact, okay? So you are going to do this, okay?
Yes, sir.
Yeah. And then you are going to apply and see how at the end you can decide and print the state of your bicycle to see that you are printing the gear, you are printing the cadence, you're printing so that you can have that visibility. So this is the second assignment for you. It has to do, you will need to combine this and this to have the results that you want. Because when you look here, right? When you look here, there is no main method. Have you noticed that? There is no main method. But the main method is here. Public static void main. Your program will always run when you have the void, the main method. The main method is what will always execute the program. Okay. Okay, about assessing class methods, I think it is not very critical. We have seen to access, you need to put the class and then you put dot, the name of what you are accessing. Okay, so we have less than 10 minutes to go. The class is indicating. Okay, we have class specifications. We have seen some of the specifications. You could have public, you could have abstract, you could have final. We are going to see some of these. We are going to see these ones, especially the extends, implements. When you want to do interfaces, we are going to see them. So these are some specifications that you are going to, that you can apply to your class. Okay, you can decide to say public class, or it's an abstract class, or it's a private class, finite class. It extends, it implements. Okay, we are going to see that. Okay. All right, so we have another code that is talking about the volume, that you have a box and a method that is displaying the volume of the box. So you can have a box, you can have what, the length, the width, the height, and then you can have a method to set the length and then maybe to calculate the volume. Okay. So I think we will end there for today. And ending there, I think we have covered what we were supposed to cover, because all these other ones are little details. You can go through them and you ask questions. Okay. So what I will be expecting from you, I will create the assignments on the platform where you can upload. I will be expecting you to first of all show me proof that you have installed your NetBeans, your Java development kit, and your NetBeans or your Eclipse. You choose which one you are comfortable with. NetBeans or Eclipse is fine. And that you have run the first program, and that you have run it with Hello World, and you have run also displaying your name, okay, with the screenshots. You understand the concepts, and then you need to show that, which was the second one? Okay, this was
bicycle.
this one about the gear of bicycle and that.
Yes,
Bike. Okay. So basically there are two. There are two. For the start, we have just two or three. The first one is the installation of your NetBeans and your JDK or Eclipse, and the second one is the compilation of all these codes. Okay. So any questions before we go? Somebody is singing already the night, how do they call it? Night songs to sleep. Any question?
Lullaby.
Yeah. Are you the one singing?
No, sir. I'm not the one.
If it is not you, then it is Clinton. There are two persons. Okay, so any last observation before we go? Anything? Everything is fine?
Yes, sir.
Yes, sir. For now.
Yes, sir. For now.
If
Okay,
there's anything, we'll get to you on WhatsApp, sir.
all right, that will be perfect. And remember, from the onset, I encourage teamwork. I encourage teamwork. Now,
So
somebody might have installed NetBeans, and if you face difficulties installing, just meet the person and they will show you. You guys work together, you install it, and you run these things together. For me, at the end of it is that all of you, we move together, okay? And we need
Yes, sir.
to communicate, work as a team to achieve this. Okay, guys, thank you very much for your time. Thank you very much for your participation. I'm happy for your presence and I appreciate who made time. Yeah. It should be when? Next week, right?
Which
Yeah, you're
class, sir?
teaching two courses.
Sorry?
You have two
Yeah.
courses with us.
Yeah. Next week, I mean for Java programming, for object-oriented.
Yes, sir.
Okay.
It should be next week.
Yeah, then tomorrow or sometime we should have, this week we should have also the operating system.
It's tomorrow.
Tomorrow, sir.
All right, okay.
Yeah.
All right, fine. So good night, guys. I will share with you the recordings.
Okay. Thank you, sir.
Thank you.
All right, bye.
Okay.